In the JUMP journal that accompanies this module, you'll find times to campus 4x4. For this example, I'll work through the analysis the way I actually would if I were doing this as a real analysis, so I won't stop as often to point out things, although I will of course show you what I'm doing. Now the first thing I do for any new data set is go to Analyze Distribution, because I want to make sure that there are no idiosyncrasies or problems with my data. So I'll take all the columns, put them into Y, and click OK. Now the first thing I would look at is the times to campus Y column. That is, do I have extreme observations or things that don't make sense in the data? Now you'll notice we do have some extreme points that are marked as outliers by the criterion of 1.5 times the interquartile range plus the third quartile. So these are points that are far from the median, but I wouldn't consider them so outlying that I would remove them from the data set. These still make sense, and these were, in fact, real times to campus that I would observe. So everything looks okay in this column. Let's actually look that we have the right number of combinations of our route and time of day. Now the way I showed you before was clicking through each of the different routes and making sure that we have observations in each time of day. You can see this because when I click through, there are observations for each 9:30, 9 o'clock, 8:30, and 8 o'clock. An easier way to do this, and one that I would recommend, would be using Analyze Fit Y by X. And what we'll do here is actually cross route and time of day. By doing this, we'll actually get the mosaic plot that shows us whether we have each combination observed. In this case, we have equal numbers in each of the different cells, and we can see this in actually the contingency table. The count for each of our cells is 20. Now, one final way to do this that is especially useful when we have larger designs is using the table's summary option. Table summary is a way of getting statistics for combinations of factors or individual factors. What I would do here is take times to campus, go to statistics, and select N, because the statistic I want is the number of observations that are in the time to campus column. And what I'm going to do is use the grouping section. I'll actually take both of my factors at once, route and time of day, and click them into group. What this will produce for me is a table that shows me the number of rows counting in each of these combinations. Notice the number of rows, or the number in the times to campus column, are all 20 for each combination. Now this is especially useful for the analysis of variance. This will return what is called an orthogonal analysis of variance. Analysis of variance techniques are done best when you have equal numbers of observations in every cell. Now this isn't a requirement of the analysis of variance, but if there were an instance where you had no observations in one of your cells, that would be a problem. Because notice the model has no way to really know what would have happened in one of these cells if you hadn't observed it. So when you're doing an analysis of variance, especially once we get to larger designs with more than 2 factors, this is the way I would suggest you look at your data before you analyze it. Make sure you have a good number of observations and hopefully equal numbers of observations in every cell of your design. So far, everything looks okay. These data are clean and they have the right numbers of observations in all the different cells. So now we're ready to move on to fitting the analysis of variance. Let's go to the Analyze menu and select Fit Model. Like we did before, we'll put times to campus in the Y. I'll change the emphasis to be minimal report, and we'll form our full factorial between route and time of day. Notice that nothing will change here. We'll still select both factors, go to macro, and select full factorial. In fact, in setting up the model, nothing changes between our model now that is a 4x4 rather than a 2x2. We still have only one main effect of route, one main effect of time of day, and one interaction between route and time of day. That is all the same. The difference will be when we run this model, because when we run this model, we'll actually have more estimates for the different parameters. I'll expand this section just to show you, but we won't be looking at this normally when we run our analysis of variance. But notice, in order to represent the route effect, in which we had 4 different levels, we now have 3 A terms. That is, we need 3 degrees of freedom to represent the 4 means that represent the route effect. Similarly, for time of day, we had 4 different times of day we observed, and now we have 3 parameters in our model. So remember the degrees of freedom for each of these: J-1 for the route effect, K-1 for the time of day effect, and finally, to represent the interaction, we have J-1 times K-1 terms. In this case, 4 minus 1, 3, times 4 minus 1, 3, is 9 different terms. So 9 degrees of freedom to represent the interaction. Don't worry too much about those, but notice that our model requires more parameters in order to represent all the different conditions or cells in the design. Now, the main section I'll have you look at, and I would suggest you look at whenever you run your factorial analysis of variance, is this effect test section. The effect test section shows us, again, for each of the different sources in our model, the main effects and the interaction. Here, the main effect of route was statistically significant. Ignoring the rest of our model, the different routes had, on average, differences in the times to campus. Similarly, the time of day effect was statistically significant overall. Ignoring everything else in the model, the different times to day had differences in the mean times to campus. And finally, our interaction was also statistically significant. We have evidence on the basis of this analysis that we can't talk about the route effect independent of the time of day effect. Or said differently, we can't talk about the time of day effect independently of the route effect. That is, one is statistically modulating the other. Now remember, an interaction doesn't mean something necessarily causal, but it does mean that these main effects are not the whole story. That is, whatever overall effect of route there is depends statistically on which time of day we're actually talking about. So let's look through our different effects and actually see what results we obtained. Remember, we can expand the effect details section to get more details about the different effects in our model. Let's start by producing the least squares means plots. We could, for each of the different sources, click and select least squares means plot. You might remember that there's a quicker way to produce many of these analyses at once in JUMP. If I hold down the Command key, and it'll be Control if you're on the PC, and then click the red triangle and select least squares means plot, JUMP will interpret this as me broadcasting the command, which means anytime I could produce a least squares means plot, JUMP will produce it for me. So if I scroll down, you can see we have the 3 least squares means plots. First, let's look at the least squares means plot for route. Notice, ignoring the rest of our model, we can see that we do have a route effect. Gilman Drive is still the fastest, Genesee is the slowest, and La Jolla Village Drive and Nobel Drive are sort of intermediary. If I scroll down to the time of day effect, ignoring everything else that is averaging over the rest of our model, we can see we do have a slight time of day effect. It's getting faster for me to get to campus the later in the day I go. Finally, let's look at the factorial plot, the plot showing the interaction between time of day and the different routes to campus. Notice that these lines are not parallel. That is, there's something in addition to simply the overall effects that's happening in these data. Another way of saying this is the time of day effect is not independent of which route I'm taking. Notice again, for Gilman Drive, there's a slight increase in the time it takes the later I go in the day. We'll be able to test whether that increase is actually statistically significant, but just numerically right now, notice that it takes a little bit longer at 9:30 than it does at 8. For the other routes, however, it's getting faster the later I go in the day. So we would say there's an interaction in these data. That is, the route effect, what we would describe as the route effect, depends on time of day, and what we would describe as the time of day effect depends on which route we're talking about. Like we did before, I often like to produce the factorial profiler. That is, if I go under Factor Profiling and select the profiler, I can interactively click through my model to see what effects we have. Again, by dialing in a particular level, we're able to look at the other factors' effects. So for instance, if I click on Gilman Drive and look at the plot for time of day, we can see the same line we saw up here. That is, at Gilman Drive, it takes a little bit longer the later in the day I'm going. But if I were to select Genesee Drive, the plot here is different. It actually is a little bit faster the later in the day I go. So the prediction profiler is a nice way to profile your models, to click through dynamically to see what effects you have in one factor based on the level you're in of the other factor. And really, this is the definition of an interaction. An interaction is saying that what I see on the right-hand side here depends on what I've clicked in on the left-hand side. Or more formally, that the effect of time of day depends on which level of route we're currently discussing. So the prediction profiler is a very nice way to profile these interactions. All right, so now that we've done our overall analysis run-through, we can now do some follow-up tests. We might be interested in that one question I already posed. At Gilman Drive, do we think that this time of day effect is statistically significant? That is, do we really think there's a change across the time of day at just Gilman Drive? Now, an option I haven't shown you before, under the dropdown for route by time of day, is an option called test slices. Let's take a moment to show you what these are before I produce them.